We will move on to the seventh sum of checking the system property, causal or non-causal. The given question is y of t equal to integral minus infinity to t x of 3 into tau into d tau. So what we do is whatever the t form, we need to replace it by tau. So tau is equal to t. If we are replacing it, we'll get inside the integration, we'll get x of 3t. Okay, so for t equal to tau, we get this. So by the simple logic itself, we can understand if t is a value, t is for any value 0 or whatever it is, t equal to 1 at any time it depends on the 3 times of t, x of 3t. So at t equal to 1, y of t is x of 3. So x of 3, it means that future value. So depends upon the future value of input, because now the value of t is 1. So for example, if we take for x of minus infinity, it depends on x of minus 3. So it depends on the past input. But for one value t equal to 1, it is found to be depending upon the future value of input. So how we conclude? The system is non-causal. The system is non-causal system. It's very simple example. And we move on to the last type of this causal and non-causal, where y of t is given as d by dt of x of t. Y of t equal to d by dt of x of t. So as like integration, we use the concept of integration as area under the curve. We have a simple definition for differentiation as it is the slope of the signal. It is being represented as slope of the signal. So for to elaborate this sum, we have taken the simple example, the slope of slope like this. We have to work it out whether the signal is causal or non-causal. We have taken 3 values. For example, one value is 2 and 1, 2, 3. 3 examples, 3 example points we have taken. And if you are seeing the graph itself, the slope is nothing but the d by dt of x of t. And we need to find to check the causal and non-causal. We have represented, before going to that, we have represented that this thing, for example, 2 and 1, 2, 3 are the 3 points. We are take 2 points at one step. For example, if you are taking 2 and 1, the first 2 points, then this is your past input and this will be your future input. Okay, so we have taken case 1 for point 1 and 2. So the slope of this is a straight line which depends on the past input and present input. I repeat, we have taken point 1 and 2. 1 and 2, d by dt of x of t is defined as slope of the straight line, slope of a straight line which depends on past input and present input, past input and present input. So the system at this point is said to be causal. We come to the case 2. As you all aware, 1 and 3, point 1 and 3 is depends on if t equal to 1 is the example we have taken. 1 and 3 we have taken. At any point t, it depends upon the present and future input. It depends on present input and future input. If t is 1, it depends on the 3 value also. So slope depends on the future input. So the system is said to be non-causal. System is said to be non-causal. Generally, by studying all these sums, we came to know that causal system is the preferable one, which shows the realistic example, that is real life examples, all are being said to be causal, because time value depends on the past and present. Output at any time depends on the past and present value of input. we don't know about the future input, so it is all the causal signals, all the practical example, physical signal generator, we started with that example. All the realistic real life examples are causal. Non-causal systems cannot be physically realizable because it depends on the future input. So the conclusion is causal system is always preferable one. Okay, so you can take down the homework sum for this session. You can copy down the question. Y of t equal to integral minus infinity to 2t x of tau by 2 into d tau. X of tau by 2 into d tau. Second example, y of t equal to integral minus infinity to t x of tau minus 1 into d of tau minus 1. And the third example is y of t equal to integral minus infinity to 2t x of tau into d tau. One is with x of tau d tau, x of t minus 1 dt of t minus 1. One is with the limit 2t x of tau minus 2 into d tau. For all these three sums, you should check whether the system is causal or non-causal.